Right, so we're going to have a look at some simple big data analysis with some real data. So we're going to use Pandas, which is a library that allows us to do our analysis and to get some statistics from our data. So the data set that we're going to use is the winnable battle risk factors and health indicators, summary report by state. So this data itself contains real data from 2014 and involves each of the states reporting on things like the infant mortality rate, heart disease, death rate, stroke, death rate, and so on. And what we want to do is to see if we can find a correlation between some of these factors. I've also added the average income for each state too, so we can look at that as a factor. Okay, so you can use this page here to look at the evaluation, but we'll be using just our Python code. Okay, so here we go. So we'll just get started. And first thing we're going to do is we're going to just modify our little program here. Okay, so I've got a data set here. There it is. And what I'm going to do is I'm just going to read in the CSV. We defined our pandas here as PD as the object, and we're going to read in CSV, and this will create our object here. Okay, so the first one isn't really going to show very much, but we'll just run it anyway, just to show. And there we go. Okay, so that's printing out the object that we have. So that's the data that's contained inside the object that's created by reading in the CSV file. Okay, so there we go. There's all our states, and it's printed it in a nice little tabular format. So I've added on the average income per state, so we can analyze that. And it prints fairly nice, where it gives a new line there, and then we can match up with the second set. So we can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different columns here. Okay, so that's our first bit. So now what we'll do is we'll go ahead and we'll just modify our file. And the first thing we're going to do is that, let's say we only want to have a little peek to see what's actually in the data set. So for that we'll just print the first 3 rows. Okay, so that's the national statistics, and that's Alabama and Alaska. So that's printed the first 3 values there. So for our next one, what we'll do is that we'll actually have a look to see the number of rows that are in the data. So for that we just do length of var, and it returns back 52. Okay, so that's the number of records that we have in there. We now want to look at the columns. We want to peek inside and look at the columns that we actually have within our pandas object. And we can see here there they are there. Okay, so these will be the names that will refer to our columns. So when we refer into a column inside our data, then these will be the names that we'll actually use. So rather than saying 0, 1, 2, 3, we'll actually use these names, and that make our program a little bit easier to read. Now what we'll do is we'll have a look at the data types. So sometimes we can have integers or floating point values or strings and so on, or complex data types. So this property here allows us to be able to look at the columns and the different data types that we have. So most of them are floating point. The region state is a string, and then these ones are floating point 64-bit, and the last one is as average income is an integer, 64-bit integer. Now what we'll do is that we'll actually have a look at one of the columns. So it's a region state, and we can refer to it like that. Okay, so that's the great. Okay, so now let's look at our infant mortality rate, and we should be able to print out just that single column. Okay, so there's the infant mortality rate in there. And then if we want, we can actually look at several columns at the same time. So we use a standard type of data set here. And this will allow us to print out region state, infant mortality rate, and heart disease, hopefully. And there it is there. Okay, so that's really just an order of what we have in our CSV file. And then it gets much more interesting when we actually look at some basic statistics on our data. So for that we use the describe method. So there is our object, and we'll just describe here, and I'll save that and see what we get. So in this case, what it does is it prints out the number of values that we have, the mean, standard deviation, maximum value, and the quartiles. Okay, so you can see it. We can look at standard deviation for things, hopefully if it's a normal distribution. So we can also look at the values, and again we can do a peek at the rows that we have. Okay, so this is just going to sort our infant mortality rate, and we're just going to look at the top 3 values. Okay, so we're taking infant mortality, and we can see it's taking the lowest values. So the lowest values for our infant mortality are from Massachusetts, Iowa, and Vermont. And we can do it in the opposite order. So we can actually find the worst states in terms of the infant mortality rate. So that's the number of children dying before their first birthday per 1,000 of the births. So the best ones were Massachusetts, Iowa, and Vermont, and the worst rates 9.6, Mississippi, Louisiana, and Alabama. Okay, so already we can make a slight judgment on our data, but what we really want to see is the correlation between our data sets that we have, or the columns. So what we have is the correlation method, and this will allow us to be able to see how strongly correlated the columns or the data that we have are. So a value of around 0 is no correlation and completely random, but a value of +1 is a direct correlation. So obviously between infant mortality rate and infant mortality rate we're going to get 1, which is direct correlation. So a positive means that we have a positive correlation, which means if we increase one of the variables we also increase the other. So an increase in infant mortality in this case leads to an increase in heart disease death rate. A negative means the opposite. If we increase one, then we get a decrease in another one. So values above 0.6, 0.7 on to 0.8, 0.9, and then up to 1 gives us a fairly strong correlation between the values. Values around 0 and 0.1 really mean that the variables are not correlated very well. So I can see in this case the infant mortality rate has a fairly strong correlation with heart disease death rate, with cancer death rate, and then has a negative factor with income. Okay, and then we can go around and pick these things off. So for heart disease, we have a strong correlation, fairly strong correlation with cancer death rate. With stroke, as you would imagine, with stroke, then heart disease is fairly strong there, and so on. So when it comes to income, we can actually see there that the income has a correlation with stroke death rate. Okay, so this allows us to be able to see if our columns are correlated against each other. So if we want, we can actually just pick off two of the columns in our data and very quickly see if we have a correlation between these two factors. So in this case, this is heart disease death rate and infant mortality. You can see it's fairly strong, 0.72 there. Okay, so we can also look at covariance, and covariance looks at how strongly the parameters are bound. So we can run that, and we get a, oops, let's save that one. Okay, let's save that and see what we get. There we go. Okay, so we can look at these values and see if we have some correlation. Then we can actually filter. So in this case, we can filter if the infant mortality rate is greater than 4.8. This basically just gives us a true or false. Okay, for the values that we have. But we can then actually define it so that we can actually show the rows out that have an infant MR of more than 7. Okay, so these are the states that have an infant mortality rate of more than 7. And then we can add a logical decision. So in this case, we're taking 2 of our columns, the infant mortality rate and the stroke death rate, and it should filter out for values of a stroke death rate greater than 45 and for the infant mortality rate to be greater than 7. Okay, so we can use other operators, logical operators in there too, to operate on our data. Okay, so that shows how we can analyze using pandas. Where it gets really interesting is that when we actually start to plot our data. So we can use pandas and we can integrate it in with some charting. So in this case we use the MATLAB plotlib and we create an object called PLT. So we're just going to read in our data again, and then what we're going to do is we're going to plot our x-axis and our y-axis. Okay, so in this case we're going to take our x-axis is infant mortality rate and our y-axis is heart disease rate, death rate, and we'll see if we can find a correlation. Okay, so just let's do that. Okay, so what we're going to do is that we're going to create a scatter graph, and we'll take off the one column at a time, and we should be able to plot that. Okay, so there we go. So hopefully we've seen that there is a correlation between heart disease death rate and infant mortality, and this is the plot for each of the states. And we can see here, roughly, as we increase the infant mortality rate within inside the state, then we can see that we will possibly increase the heart disease death rate. So there is a correlation. We've seen a correlation between 0.6 and 0.7 from a previous result. Okay, and also we've got, if we want, we should have stored a file there. Okay, so we can save our file as a PNG or an SVG file just by saving our plot there. So if we want, we can also, we'll look at one that doesn't have a strong correlation. So I think the motor vehicle death rate doesn't correlate with heart disease, but we'll just give it a try, so we can save that. And let's run that one. Okay, so there you go. As you can see, that's a fairly random type of thing there, and from our previous analysis for our correlation between heart disease death rate and motor vehicle heart disease death rate, and motor heart disease death rate, we can see 0.36, so it's not a strong correlation there. If we actually look at the drug poisoning DR, we should find that there's virtually no correlation there. So what we'll do is we'll just open that one up. Okay, so this is correlation between drug poisoning death rate and the motor vehicle death rate. You can see it's almost got a zero correlation, 0.04 between the motor vehicle death rate and the drug poisoning death rate. So let's plot that, and it should be random, hopefully. There you go. Okay, so we can say here, even just by looking at it, that's a fairly random type of distribution there, and we can see there's no correlation between drug poisoning and motor vehicle death rate. So one thing that I've added to the data set is to look at income, to see if income has an effect on our health correlations. And one thing you can notice is that all the values are actually negative values. So what we'll do is we'll go back to this one. So this page here is actually just plotting what we saw there. So it's using the same code that we used there, but we can generate it from our web interface. Okay, so this is our infant mortality rate against, this is heart disease death rate against infant mortality rate. So there you can see the correlation. And this time if we look at stroke, we can see there's a correlation there But then when we look at motor vehicle death rate, it's much more random. But let's look at average income. And what you can see with the average income is there's a negative slope here for our correlation. All the other ones are positive. So in this one we can actually see there is some correlation between the infant mortality rate and average income. Okay, so as the income, what we'll do is we'll plot that on the x-axis, and we'll put that one there. Okay, so as you increase average income, it's likely that the trend is downwards. Okay, so that's so we'll take average income again, and we'll look at heart disease. Okay, so again you see this negative trend here. So this is the lowest average income, and this is the highest, and we can see here there is a negative. So the higher the in general the heart disease death rate, the lower the income. If we look at stroke on the Y, again there is this negative trend here. Suicide rate, fairly random there. The homicide death rate against income, again not a strong correlation there. Drug poisoning. If we look back at our correlation figures, we should be able to actually see this not a strong correlation there for the motor vehicle death rate. We can definitely see that the higher the income, the lower the motor vehicle death rate is. You can see that slope downwards there. For the cancer rate, cancer death rate, there is small correlation, but again it's gone downwards there from them. Okay, so that's our analysis with pandas. And so if you want, then this page here will give you a quick analysis of it. Okay, so there's head, and if you want, you can actually put in some data here, and it should process that. Okay, and that's been an outline of big data analysis using pandas.